How are you, my dear students in organic chemistry? Today, we will be discussing about our lesson 3, chemical reactions of alkanes. Let me ask you a question, a personal question. How do you react to a criticism? Is your reaction produce a favorable or unfavorable result? Chemical substances reacts with other substances in various ways. For example, when gasoline is heated or reacts with heat, then it will produce a flame. Iron nail becomes rusty when exposed to air. Acetone evaporates easily in an open container. Or the mothball or alkampor sublimes, meaning they evaporate from solid state directly into a gas when exposed to air. Our lesson objectives are the following. First, we want to discuss the reaction of alkanes and other hydrocarbons. And then we will balance the chemical equation of the combustion reaction. Natural gas, gasoline, and fuel oil are alkanes that undergo highly exothermic combustion reaction. Example is the reaction of methane with the molecules of oxygen gas forming gaseous carbon dioxide and molecules of water plus the release of energy. When we say exothermic reaction, it is any process that gives off heat. That is, there is a transfer of thermal energy from the system to the surroundings. The combination of alkanes with oxygen gas producing energy in the form of heat is known as combustion. More precisely, combustion is defined as a chemical reaction with oxygen gas in which alkane is converted into carbon dioxide and water with the release of heat energy. Combustion is also called burning. It is a reaction in which a substance reacts with oxygen gas, releasing energy in the form of light and heat. It is also a reaction that involves the oxygen gas as one of the reactant. The complete combustion will produce carbon dioxide and water and accompanied by the release of energy in the form of heat or light. The general formula of combustion of alkanes is the alkane plus the oxygen gas yields or produce carbon dioxide and water as the product. So, in a chemical equation, we can see that there are two sides of the chemical reaction or the equation. The reactant side and the product side. So the reactants are the starting material in a chemical reaction. Well, these are the chemical substances that reacts or that combine together. While the product are the substances formed as a result of the combination or as a result of the chemical reaction between the reactants. Let's take a look on how the simplest alkane, the methane, undergoes combustion reaction. So the methane, the CH4 plus the oxygen gas yields carbon dioxide plus water or H2O. So we will read this as The methane reacts with oxygen gas to form carbon dioxide and water. Here, our reactants are the methane and the oxygen gas, and the products are the carbon dioxide and water. So we will read this as methane, or the CH4, reacts with the oxygen gas, the O2, yields or produce carbon dioxide plus water, or H2O. This product is actually constant because a combustion reaction yields a constant product. That is the production of carbon dioxide plus water. And of course, accompanied with the release of energy in the form of heat or light. This chemical equation is correct. However, we need to balance it to be consistent with the law of conservation of mass, which states that the total relative formula masses of the reactants is equal to the total relative formula masses of the products. To check if the chemical equation above is balanced, let us count the number of atoms of each element in the reactant side and in the product side. So, in the reactant side, we have to account for the number of atoms of each element. So first, we have the carbon, then we have the hydrogen, and the oxygen. And for the product side, we have also the carbon, hydrogen, and oxygen. So let's see, and let us count the number of atoms of each element in the reactant and the product side. For the carbon in the reactant side, we have one atom. One atom because carbon has no subscript. So it indicates that carbon has only one atom. Hydrogen has 4 subscripts, so it has 4 atoms. And oxygen has 2 subscripts. The number written on the lower side of the element is 2. So that's the subscript. So our oxygen has 2 atoms. On the product side, we have carbon, 1 atom, hydrogen, 2 atoms, oxygen, 3 atoms. The equation is likely to be unbalanced. That is, the number of each type of atom on the reactant side differs from the number of atoms on the product side. You can see that the number of individual atoms of the element on the reactant side and on the product side are not the same or are different in number. So they are unbalanced. In general, we can balance a chemical equation by the following steps. Number 1, identify all the reactants and products and write their correct formulas on the left side and the right side of the equation respectively. So here we have the methane. The chemical formula is CH4. Reacts, meaning plus, we will read that as reacts with the oxygen gas, O2, that's the chemical formula. The arrow represents or means yields or produce. Produce CO2, that's the carbon dioxide, plus the water. Begin balancing the equation by trying different coefficients to make the number of atoms of each element in the reactant side and in the product side the same. So going back to our chemical equation of how the methane reacts with oxygen gas forming carbon dioxide and water, let us first identify the important numbers here. So we can see a number written at the lower right side of an element is this called subscript, while the number placed on the beginning or in front of the element symbol is called the coefficient. So in a chemical reaction or equation, we cannot change the subscript, but we can supply, or we can adjust, or we can decide on the coefficient. What number are we going to place or to use as a coefficient? So in the original chemical reaction of methane with oxygen gas, we can see the carbon and all other elements in the reactant side and on the product side are unbalanced. But now, in the example here, we can see that there are already a coefficient used or placed in front of the element symbol. The coefficient used here will help us to balance the chemical reaction. So now, how are we going to balance the chemical equation here? So first is we will take a look at the element symbol or the element on both sides, on the reactant and on the product side. For the carbon, on the reactant side, we have one atom. Because carbon has no subscript, it means it has only one atom. On the product side, carbon has also one atom. Okay, so they are now the same, or they are the same. They have the same number of atoms. For the hydrogen on the reactant side has 4 atoms, indicated by the subscript 4. On the product side, originally, because H2O or hydrogen has a subscript of 2, has only 2 atoms. But because of the coefficient 2, because we supplied a coefficient 2 in front of hydrogen, then we can now multiply the subscript with the coefficient 2. So by supplying a coefficient 2 in front of hydrogen, we can now have 4 atoms of hydrogen because we will multiply the coefficient 2 or the subscript 2 with the coefficient 2. So that is 2 times 2 is 4. For the oxygen atoms, on the product side, originally it has only 2 atoms. Because H2O, oxygen has no subscript, so it has only 1. However, due to the coefficient we place in front of hydrogen, we will now multiply 1 times 2. 1 times 2. So that's 2 plus another 2 atoms of oxygen on the carbon dioxide. So total, we have 4 atoms. On the reactant side, we will multiply the subscript 2 with the coefficient we supply or we place 2 in front of oxygen gas. So to make it a balanced chemical equation. So balancing chemical equation like this, we need to think of a number, a coefficient, a number that we can place or we can supply or we can use in order to have a balance or the same number of atoms in our reactant side and in the product side. So we examine the number of atoms of elements in the reactant side and in the product side. And since the number of atoms in the reactant side and in the product side are already the same, then we just write their number of atoms. So for the reactant side, carbon, 1 atom. On the product side, the carbon has also 1 atom. There are 4 hydrogen atoms in the reactant side, while only 2 on the product side. That's on the original equation. So we place coefficient 2 in front of hydrogen or in front of H2O on the product side and multiply the subscript 2 of hydrogen, giving us a 4. So on the reactant side, we have hydrogen has 4 atoms, and on the product side, hydrogen has also 4 atoms. For the oxygen, notice that the number of oxygen in the product side becomes 4. Why? Because we multiply 1 subscript. The oxygen has no subscript, so automatic there is 1 atom. 1 atom of oxygen times 2 with the coefficient. You multiply it with the coefficient. Plus the oxygen on the carbon dioxide, which is 2. So 2 plus 2 is 4. On the reactant side, we place or we use coefficient 2 and place it in front of oxygen to make it 2 times 2 is equal to 4. So for the reactant side, we have oxygen, 4 atoms, and on the product side, oxygen is equal to 4 atoms. So by placing the right coefficients, we already have a balanced chemical equation of the combustion of methane. So another example is the combustion of alkane, ethane, C2H6 with a chemical equation. So this is correct. That is ethane, C2H6 plus oxygen gas yields or produce carbon dioxide plus water. The formula or the chemical equation rather is correct, but it's unbalanced. As you can see below, if we will account for the number of atoms of elements in the reactant side and the product side, we can see that they don't have, or they are not the same in the number of atoms. So for the carbon, only two atoms on the product side. On the reactant side rather. For the product side, we have only 1 atom. Hydrogen, 6 atoms on the reactant side, 2 only in the product side. And oxygen is on the reactant side, you have 2 atoms, while there are 3 atoms on the product side. So it's unbalanced. So how we can write and balance the equation for the complete combustion of ethane? So there is an explanation here as the source of Socratic.org. I get it from the internet source Socratic.org, explaining how we balance the chemical reaction of ethane, the combustion reaction. So it's a little bit tricky, but we can see here that we will initially arrive at this balance or at this balancing equation. C2H6 plus oxygen gas yields 2CO2 plus 3H2O. But in this case, you can see that you have an odd amount of oxygen gas on the product side. That is 2. And in this case, you have to find the common factor of the oxygen on the product side and 2. Because of the oxygen gas diatom. Therefore, 14 would be the lowest common factor of 2 and 7. So begin balancing equation. We will use coefficient 2, 7, 4, and 6 for this chemical reaction. You can see by coefficient, by using the coefficient here, that the chemical equation of ethane or the combustion of ethane is already balanced. So just study how it was done. So, combustion does not only apply to the alkane, it may also happen in hydrocarbons. So take the case of glucose, for example. Glucose, it's kind of a sugar with chemical formula of C6H12O6 plus reacts with oxygen gas to form carbon dioxide and water. Again, we need to balance this chemical equation because counting the number of atoms on the reactant side and the product side, we can see that they are unbalanced. So how are we going to balance this? In this example, you can see that we use a coefficient 6 on the reactant side and 6 coefficient also on the product side, both for the carbon dioxide and water. So by using this, let's check if this is already balanced. So in the reactant side, we have carbon, which is 6, hydrogen is carbon, 6 on the reactant, and on the product, we have also 6 atoms of carbon. Hydrogen is 12 on the reactant, on the product 6 times 2, that's 12. Oxygen, that is 6 times 2 is 12 plus another oxygen, another 6 oxygen, that's 18. For the product side, we have oxygen, 6 times 2 is 12 plus another 6, that is 18. So another example is the combustion of sucrose, another form of sugar, commonly known as the table sugar. So C12H22O11, that's the chemical formula of sucrose, reacts with oxygen gas to form carbon dioxide and water. Again, this is unbalanced chemical equation, so we need to balance it by finding the right coefficient. So in this example, you can see that we use coefficient 12 and 11. And try to examine this one, how this chemical equation was balanced by using this coefficients. So carbon on the reactant side is 12 on the product because of the coefficient 12, then carbon becomes 12 atoms also. Hydrogen is 22 on the reactant and 22 also on the product because we have 11. Hydrogen rather is 22 on the reactant side. On the product side, that is 11 times 2. That's 22. And oxygen on the reactant side has a total of 35 atoms. And on the product, we have also 35 atoms. I just want you to study this in detail and examine this in detail so that you will learn how it was balanced. So these are just some of the examples on balancing chemical equation of the combustion of alkanes and other hydrocarbons. I hope that we can have as much as I want to have a thorough discussion on balancing chemical equation. But however, I will see to it that you will be provided with a copy of this, a hard copy of your handouts on this topic, and I will be providing you a lot more examples because in this video lesson, it's really hard for me to elaborate much and to show you a lot of examples because of the very limited time and of course with this modality of delivering this instruction. However, if you have questions or inquiries, clarification regarding this, you can contact me through my cell phone number or through our Google Classroom. You can send question or queries, and also in my personal messenger you can ask question or clarification. Thank you very much once again, and expect an exercises or a problem solving on balancing chemical reaction of the combustion of alkanes and hydrocarbons. I will be giving you a lot of exercises posted in your Google Classroom. So just wait for my instruction about that. Thank you very much, and good day to all of you.